Good morning, class. Today we are going to be doing some more work with statistical measures. We are going to be starting lesson 9.2. 9.2 deals mainly with mean and outliers. Okay, so by the end of today's lesson, we will be able to understand a set of data, answer a statistical question, which has a distribution and it's recognized by its center. We will also be able to recognize the measure center for a numerical data set, which summarizes all its data values with a single number. The first two standards, basically, what they're talking about is mean. In the next one, we will be able to look at a data chart and analyze the given data to be able to answer statistical questions. So what does mean? Basically, mean means you take all the data that you have, all the different numbers that you have, and you add up all those numbers. Then you divide it by the number of values that you added up. So if you have like 7 different numbers that you are adding up, you're going to add up all those 7 numbers, and then you will divide it by 7 because that's how many numbers that you added up. And whatever answer you get, that is called the mean. Okay, so let's look at some practice problems first. First practice problem, let's look at this graph. This bar graph shows the number of home runs hit by 10 players on a baseball team during the regular season. Which player hit the most home runs? That's correct. If you look at player number 8, he hit about 31 home runs. Good job. Is that a statistical question or non-statistical? That is a non-statistical question because it says which player. You are only coming up with one answer. Of the 10 players shown, what percent hit more than 20 home runs? Once again, it's asking for a percent. So this would be a non-statistical question. You better only come up with one answer. Of the 10 players shown, what percent hit more than 20 home runs? Well, if you look, this should be pretty easy because there's only 10 players. So each player represents 10%. More than 20 home runs, you find this line. It has to be more than 20, so you have 1, 2. If you have 2 players above that line, what percent hit more than 20 home runs? That would be 20%. Okay, what percent hit fewer than 12 home runs? Well, find the line for 12 home runs, which is right here, and you can count 1, 2, 3, 4, 5. Can we count this one? No, because he did hit 12. So if we have 5, what percent is that? Very good. 50%. Okay, next warm-up question. Okay, I briefly told you what is the average value of the data. What I want you to do is I want you to add up all these numbers. 2 plus 2 is 4, plus 3 is 7, plus 4 is 11, plus 1 is 12, and plus 2 is 14. What you do is to find the average, you divide by how many numbers you added up. You added up 7 numbers. 1, 2, 3, 4, 5, 6, 7. So 14 divided by 7 would be 2. The average value is 2 TV shows watched each day this week. So I want you to look at number 2, 3, and 4, and I want you to press pause, and I want you to figure those out by yourselves. Okay, so I went ahead and did number 2, 3, and 4. Let's share our answers. If I added up the total number of points scored by each starter on the team, I added 22, 18, 15, 6, and 4. I came up with 65. What you should do is you should be adding these things twice, because if you're going to make a mistake, it's probably going to be in your adding because you're going too fast and you refuse to double check. So please double check your adding. I came up with 65, and then I divided it by, well, there's 5 starters on a basketball team. 1, 2, 3, 4, 5. If I do 65 divided by 5, I come up with 13. 13 points was my average by each starter on this basketball team. Now, how many new messages do you get in your inbox each day? Well, number 3, you add up 2, 5, 7, 2, 3, 2, and you will get 21. Divide that by 6. Mr. D, 6 doesn't go into 21. Oh, yes, it does. This is when you have to start using decimals, dropping zeros. Come on, you remember how to do this. Let's not get lazy here. 21 divided by 6 would be 3.5 or 3.5. 3.5 messages per inbox would be the average. Now, minutes spent getting ready for school. You got 45, 53, 65, 37, 29. First off, who the heck takes 65 minutes to get ready for school? Oh my gosh. I'm ready. Let's go. Okay, so enough about me. You add up all these numbers, you get 229. You divide it by the 5 people that they asked, and you will get 45.8 minutes is the average time getting ready for school. Tell you what, if it takes you 45 minutes to get ready for school, something is wrong. Okay, let's move on to our lesson, though. But before we do, here is our first picture. Just to make sure you're watching these videos. What animal is that? Yes, that is a monkey. M-O-N-K-E-Y, just in case you didn't know how to spell it. Okay, let's move on to our first example. Okay, so let's go ahead and solve this one together. It says a table shows a number of text messages sent by a group of friends over 1 week. What is the mean number of messages sent? Okay, what we are going to do is we are going to add up these numbers. Text messages sent. Mark had 120. Laura had 95. Stacy had 101. Josh had 125. Kevin had 82. Maria had 108. And Manny had 90. Okay, so go ahead and press pause. I want you to add those up. Okay, I don't know about you, but I came up with 721. Now, what you do is you take those numbers and you divide it by 7. So we can do this really quick. 7 divided by 7 is 103 text messages sent. Oh, sorry. 103 text messages sent. Okay, so we're going to do another problem, but I want you to do it primarily. So 1 second, please. Okay, I want you to find the mean of this data. Once again, you set up the problem like this. You have to add up all those numbers. Then if you count how many numbers you added up, you got 1, 2, 3, 4, 5, 6. Divide that by 6, and that's going to equal... Oh, you thought I was going to give you the answer? Yeah, not today. Go ahead and press pause, and I want you to figure this one out by yourself. Okay, so if you add up all these numbers, 30, 81, 50, 24, 15, and 64, I came up with 264. Now we have to divide that number by 6. And that should equal, I hope you got it, 44. The mean of this data would be 44. Did I show my work? You better believe I showed my work. It's right there. I'm not doing anything that I wouldn't expect. I'm not making you do anything that I wouldn't do myself. So there's my work. I hope you're showing your work. Thank you. Here's the next animal that I'm showing you. Yes, that's an easy answer for your problems in your homework today. I just want to make sure you're watching these videos. So, that is a rhino. In case you don't know how to spell it, it's R-H-I-N-O, rhino. Once again, R-H-I-N-O. Welcome back. The next thing we're going to do is we are going to look at a graph, and we are going to be able to answer some questions about it. This double bar graph shows the monthly rainfall amounts for 2 cities over a 6-month period. Compare the mean monthly rainfalls. So basically what this question is asking is, what is the mean average rainfall for city number 1 and what is the average rainfall for city number 2. So, looking at city number 1, which is the darker bar, you would have to add up 3.5, 2.2, 1.9, 2.1, 2.5, 3.4. Then what you do is you divide it by 2, 3, 4, 5, 6. Divided by the 6 months. So go ahead and add up those numbers and divide it by 6. City number, if you did that, it should look like this. City number 1 has an average of 15.6 divided by 6, or 2.6 inches of rainfall. Okay, so now that you know what you have to do, go ahead. I want you to figure out city number 2. Go ahead and press pause and add up 1.7, 1.6, 2.2, 2.1, 2.7, 1.7, and then divide it by 6. Go ahead and press pause now. If you did that, you should have came up with 12 divided by 6, or 2 inches of rainfall on average. So what this means is city number 1 has more rainfall on average than city number 2. Okay, our next example is we're going to look at this problem. It says the table shows the heights of several Shetland ponies. Identify the outlier. Remember, outliers were like oddballs, like really far off. So what I want you to do now is I want you to draw a box plot for this data. So go ahead and press pause and go ahead and give me a box plot of this data, please. Okay, making my dot plot, I see that 28 is an outlier. That's the biggest oddball there. That's throwing everything off. Okay, so what it wants us to do is it wants us to show what that outlier does to affect our data. Let's go ahead and figure out the mean of our data, including our outlier first. So we have to add up all these numbers. 40, 38, 37, 38, 39, 37, 40, 28, 42, and 20. 1, 2, 3, 4, 5. Once again, I'm making sure that I just have 10 numbers to add up. Go ahead and press pause. I'm going to let you add them up. Okay, so I came up with 379, as you can see. If I divide that by 10, I don't even have to do the division because I know whenever you divide by 10, all you do is move the decimal point one place to the left. So our mean with our outlier equals 37.9, let's not forget our label here, inches. Our mean without our outlier, we will figure out right now. And what that means is you have to do the same thing you just did, but let's not add this 20, let's not add that 28 in there, okay? Let's not add that 28, and then we're going to not divide by 10 anymore. We have to divide that by 9 because we are using only 9 numbers because we're getting rid of that outlier. So go ahead and do that. Okay, so I said you had to figure it out without the outlier. So I took my 379, I subtracted my 28, I got 351, and then I divided 351 by 9 because there's only 9 numbers now. 9 divided by 351 is 39. So our mean without the outlier is 39 inches. So which data better represents the average height of a Shetland pony? Well, I would look at the ones without the outlier. Okay, 37.9 inches is the average height. This 39 is throwing the average a little bit off because this outlier, this is a little short guy. Okay, over here, this guy's a little short guy. So we get rid of that and we get the real number, which would be 37.9 inches would be a better representation. Once again, here's my last animal that you need to see. Pig, P-I-G.